and it has started. So our speaker today is Bret Fisher. Bret is a Docker captain for those who are not aware of the program. Docker captains are Docker users who are A, power users, and B, very strong advocates for Docker technology. So it's a very rare, I think, and Bret can nod if I'm correct, there are less than 100 Docker captains in the world, 5 of which are in Virginia because we're special. And Bret lives in Norfolk, Virginia, which is roughly the southeast corner of the state along the Atlantic. And our talk today is mainly going to be informal. Bret's going to do a bunch of demos, and we'll be taking questions. So feel free to speak up and ask if you have something you want to know about. So without further ado, I will pass the torch on to Bret, and thank you for joining us, and take it away.
Thanks, John. John and I met a couple years ago at a Docker event, I think. And we have a shared history of loving all things computers, hardware, software, Linux. I used to walk around with my free BSD shirt long time ago. So I was a big fan of the BSDs and all that stuff. So it's fun to, I don't think I've actually got to speak to a group of diehard Linux people. So that is actually, this is the first. I'm pretty excited about that. Because obviously, you know, it's easy to like Linux nowadays, where it's everywhere. But you know, 20 years ago, it wasn't so popular to run into Linux geeks. So it was pretty exciting back then to actually run into somebody that knew. So I just realized I'm going to turn down the audio a little bit in case there's a little feedback on the doorbell thing. So this is a Zoom. I mean, like we're hanging out like we would in the real world. And whenever I speak at meetups, the first thing is, if you're in chat, do I sound good? Is the audio okay? Secondly, yeah. Like this isn't a presentation. This is not a webinar, right? So I want it to be more of a conversation, answering your questions, demoing things that you have questions on. One of my favorite things to do is to see if I can actually pull off a demo of the random question that someone asks in a talk. So that's what this is all about. I have 0 slides because I didn't want to put you to sleep with just a bunch of demos. We can all watch YouTube videos all day long anyway. So what I wanted to really do was make it about what you're interested in and maybe what the group would vote on. So I actually created a little poll. I'm going to throw this in chat instead of using the Zoom polling feature, which if this doesn't work, we could totally do that. But I thought if we've got a bunch of people in the room and they've all probably got different interests about containers, they probably have different knowledge levels, different experience levels. What could we do? What can we talk about that would engage the most of us, like actually have a meaningful conversation about it? So let me paste this in and see if this works in chat. So in chat, I put a poll junkie survey. And so while you're clicking on that link and getting with, it's a free website, so dealing with the ads and all that, and actually basically my goal is I threw in a bunch of different topics that, and what I didn't throw in there was I didn't mention security and all sorts of other things. So just click on all the things you are interested in talking about, and the ones that are ranked the most or clicked on the most, I will start our conversation off with. And of course, you're always welcome to interrupt me with a audio question. Like John was saying, when you're not talking, try to be on mute so that we're all probably working and we're all at home at this point. So background sound can be a problem. So or type it in the chat. I'll be watching chat the whole time here. And I've got all my stuff set up. Everything's ready to go for whatever demo, whether it's Docker, Kubernetes, containers. I got a whiteboard. We could go through some of that stuff. We could dive into specific topics. So I only had like 10 or 12 topics on this. And so I will wait a few minutes for everyone to kind of vote on what they're looking at. And while you're doing that, I'm just going to do a little bit of intro about me, because move my little head over there. In case you don't know who I am and what I do, I've been saying I'm in DevOps for like 5 years, but you can see gray in my beard. I've been doing IT since I was 18 in the U.S. Navy in the early 90s. So I've predominantly been on the operations sysadmin side, so managing Linux, Windows, Solaris, mainframe, HP Unix, AT&T mainframes, like you name it, I've done it. I was around when we did the mainframe to PC conversions, and we were actually plugging mice into PCs to put Windows on them. I went from thicknet to thinnet, and I've done everything since. So I have a perspective on what containers are in terms of the grand scheme of our lives and how this affects things like the cloud and data centers. So I could talk forever about that. But what I do on the internet now is, besides just consulting with companies on their DevOps practices, because I feel like most of my career has been around helping developers get their code into production. Whether that was a single Novell NetWare server back in the 90s, or whether it was a multinational company trying to use CDNs for video production around the globe at AWS. I've done all of that stuff. So I consult a little bit on the side, but mostly what I do now are courses. So I work from home, and for some reason my little headshot keeps moving over there. But I have a website, bretfisher.com. I'll put that up here. On that website are coupons. So if you click on the courses link in that page, it will take you to all 4 of my courses on Docker, Kubernetes, Docker Swarm, and then Docker specifically for Node.js if you're also a developer. And more are coming. We're actually doing more updates right now to both the Docker Mastery and the Kubernetes Mastery courses. So their links on that page will get you those courses for less than 15 American dollars. And most of them are at least 10 hours of video, and they're all maintained. And so if you're not familiar with those courses and you want the basics of Docker and Swarm and Kubernetes and a lot of these container things, take those courses. That's my #1 reference and resource. So the Docker Mastery course, this main one that's listed there, I think we just broke 180,000 students over 3 years in that course. So it's been very successful. Lots of people in there every day actively chatting away. In fact, that's how John and I chat through Slack. Is we have a Slack community that goes along with all those courses that have over 30,000 people in there. Not every day, but we do a lot of stuff in there talking about Docker, learning Docker. Everyone in there is learning some sort of container tooling. There's lots of channels on Docker and Kubernetes, and every day there's activity. So if you're interested in that, those are all courses you can get really cheap with those coupons on my website. And I do talking and conferences, workshops all around the world. Obviously not a lot this year. But the other thing I do is I live stream on YouTube every week. I actually just an hour ago finished that. So if you go to bret.live, that will take you to my YouTube channel. And I talk about containers and DevOps specifically. And then ergo, that means a lot of Linux, because most people's containers and cloud stuff is all Linux. So indirectly, we're talking about Linux every week live on the internet. And I have guests sometimes, and that also has a podcast. If you go there, you can find the podcast links, or just search for Bret Fisher in your favorite podcast player. You'll find that. Yes, thank you, Mark, for the URL on that. And I see. I was replying privately. I was putting up URLs, and they were going not to everyone.
And while you're doing that, I can vouch for Bret's courses. I've taken 2 of them. I own all 4, but I've taken 2 of them, the Docker Mastery and Swarm Mastery, and they are really good courses. So I fully support, get his courses, and they will help a lot.
Thanks. Yeah, I think we're almost up to 20 hours of video and video resources on the Docker Mastery course. There's a lot in there, and I still feel like it's only half done. So because of there's so many people on that Udemy platform, I'm able to constantly maintain them while they get, you know, thousands of sales a month. And it allows us to have updates to them and fixes and stuff like that. So I try to make it for the longest time, it has been the number one way that Docker's employees have been getting Docker education. So uh, it's kind of the unofficial way that Docker learns Docker. So on the poll, if I go back over to the poll results, we've got, I think Docker basics are beating out everything else. And then we've got like what's new in Docker, Docker versus Kubernetes, what's in a container, Docker internal, stuff like that. So I think we'll do that. We'll start off with a really short basics thing and then a couple of really quick demos. Of course, if you want to dive more into those, my Docker Mastery course is the best way to do that. And then we'll dive into some of the nuances of what container runtime versus Kubernetes is. And I'll do some drawing. I have my iPad over here ready for the whiteboard. And then we can get sort of in the specifics, very niche topics at the end there. What's my cutoff time, John? Are we doing an hour? 90 minutes? What are we doing?
The end time on these meetups are pretty fluid. So if you go over an hour, that's fine. Basically, as long as you want to keep educating us, I think most of the people here would be happy to stay.
Yeah, that's fine,
John. And Tristan is, by the way, you're privately messaging me. So in order to get John and the other co-hosts to answer you on your questions or see those questions, make sure that you, in the chat window, make sure you set it to everyone. I don't know if it does that by default, but that way everyone can see your chat and your questions, because I may not see everything depending on how chatty we get. Let's see, what else? Okay, I see Brandon on the call. Hello. Another Docker captain hanging out, and he'll make sure that I'm not making any mistakes. So, all right, let's talk about the basics of Docker real quick. And I'm going to try to break this down into a couple of things. We're actually gonna do a little whiteboard before we do command line stuff. And there's two ways. I mean, I've been explaining Docker to people in conferences and in workshops and web videos and all that stuff for 6 years now. I'm not sure I've got the best elevator pitch, but if you've ever done anything like Solaris jails, actually Solaris zones, we had jails, we had a lot of concepts around the idea of limiting root on a Linux machine or some sort of Unix machine for decades now, many decades. And somewhere around the mid-2000s, Linux got, I believe it was C groups first and then namespaces. I'm not sure the exact order of that. Somewhere in the 2 branch of the Linux kernel. And that allowed us to sort of give an isolated area of the operating system for a regular application to run, for a regular binary to execute. And I was not a part of that wave, mostly because I deal with normal human stuff. Like, I'm not the smartest OS kernel person on any level. Even though I've been playing around with this stuff for decades, I still feel like there's so much I could learn on that. And what was happening in the mid 2000s were there was a bunch of companies. Netflix was one of them. Obviously, Google, AWS. They were using what we now think of as containers in Linux by controlling these kernel features themselves. So they were writing bash scripts and their own Python utilities and all this stuff to basically run an executable in an isolated environment and then only give it access to resources that they wanted to give it access to, whether that was networking interfaces or parts of the file system or actual limitations on the hardware, a limited amount of memory or CPU. And Docker around 2014 came up with what I think is one of the very first utilities, and it did 3 things. One was it allowed us to run an isolated application, right? Run an app. Isolated. So that was like step 1, run an app in a way that a normal person, I say normal meaning you're not a Linux kernel guru and you're really more focused on infrastructure at large. Maybe at the time you were using Puppet or Chef or some sort of AWS command line utility. And at the time when we were all moving to cloud, we figured out that really the OS was becoming our isolation layer. So if you came from a world like I did pre-virtualization and you went into virtualization, head first, and you love the idea of getting more out of your hardware resources, you started to create individual OSs that ran a set of apps or just one app, and the OS became the isolation barrier between our applications. And then you even saw these ideas of OS images, right, where we were doing AMIs on Amazon, where we were creating an entire OS, and we had VMs with Vagrant, where we were throwing around the kernel plus the drivers plus all of the dependencies with our app. And Docker was one of the early companies that were building their own cloud. They were actually a company called .cloud in France, largely, that were competing with companies like Heroku, making it easy for you to deploy applications. And they said, at one point, let's just open source the way that we isolate the way that we run your applications. We'll open source that stuff that we do to run your apps. And they called it Docker, and it was really a command line utility. And step one was it made it a one-line command to automatically run your application and its code in a new separate part of the file system that it would namespace, and then give it all of the resources it needed through C groups, and allow it to have virtual networking and virtual file system that made it look like it was its own independent system, and meant that it couldn't access anything outside of itself on that Linux host unless you allowed it. So that was like step one that they did. But the other parts that they did that most of the other utilities we saw out there at the time didn't do was they created a new packaging format. And so this is kind of called the image. So a new package format meant that they allowed a layered approach to a file system. We'll look at that in a minute. And they allowed that to be stored on your system outside of the running application, and then use a layered file system that we call storage drivers now. And that gave us the ability to reuse those files in multiple different containers, as we were calling these apps. And so you could, in theory, download an application like Nginx plus all its dependencies, or Python plus all its dependencies, and you could run that in multiple isolated environments without re-downloading it every time. So it gave you this interface to manage that, and then the step three, the magic formula of this three sort of core reasons that Docker took off, was distribution. Distribution of those packages. And at the time, we called that Docker Hub. That was the only way to do it, but it was really nothing more than an HTTP file system and a file transfer system. So it's using HTTP as the mechanism to move packages around. And the image format allowed us to tarball up those applications and all their dependencies and move them around the internet freely. And so any one of these by themselves probably wouldn't have been that interesting if I would have predicted the future. But the fact that they were all together in a single, easy-to-use binary that really was just an automation tool. That's really all Docker is it automates Linux kernel features and now Windows kernel features to take a package from the internet, pull down the different layers, do things like security checks to make sure that it's doing the SHA hash on those to make sure that whatever's on the server is actually the same thing that's on local, and then create a brand new isolated environment to run a sort of a copy of that application that it downloaded in the image. So those three steps were what they started with in 2014. And even today, we're talking 7 years later, we just celebrated the 7-year anniversary of Docker. That is largely still today how everybody uses it. There's all sorts of whiz-bang features that are at the command line in Docker to do all sorts of new things. But the core, day-to-day, everybody using Docker, this is what they're doing. They're making packages out of their application and all its dependencies. They're moving those packages around using a registry, and then they're running them through Docker run, Docker swarm commands, Kubernetes commands. And that's catching you up to now, at least a little bit on where that came from. The short answer on the elevator of what is the difference between Kubernetes and Docker, and what is the difference between Swarm and Kubernetes and all that, is that Docker itself knows how to talk to the Linux kernel and all those different, the C groups and the namespaces and all the other little kernel features and application features like AppArmor and SE Linux, seccomp, Linux capabilities, all these fundamental parts of the Linux OS as we know it. It automates all that so that you can spin up your application and its dependencies in a new place. It only knows how to talk to one server, right? So it's talking to one daemon, that Docker daemon runs in the background. It knows how to talk to its local Linux kernel. And then Kubernetes showed up within a couple of years of Docker that said, hey, we want to run on top of Docker. And all we want to be is a web API, largely a web API, that orchestrates multiple Docker engines all over the place and allows me to do a simple command like a Docker run, but it would be, at the time it was called kube control run. And this command would allow me to run those same compatible packages on many servers, one or more servers. And I'm going to let the Kubernetes API decide how they run, where they run, what's the best server to run them on. And really, 5 years later, Kubernetes is largely still that. It's really just a distributed API that manages many different Docker engines, or as we now call them, container runtimes. And Docker is just one of them. There's three major ones. But Kubernetes can now manage all those on different servers. It can now manage them on Windows and Linux and different architectures, different builds of Linux, right? You got 32-bit, obviously 64. We've got ARM. It does now mainframe. The Linux, the Docker container runtime, as Docker calls it, the container engine, that really is just all about on a single server running an app in a container. But Swarm and Kubernetes, and there's other ones, the one's called Nomad. Amazon has their own called ECS. These are all just really abstractions that run as an API on top of Docker or one of its other compatible runtimes. And it just orchestrates across many different servers. So the simplest elevator definition of an orchestrator that I can come up with is that an orchestrator it allows you to run 100 servers or one server with the same level of difficulty. So you can spin up 100 nodes in a Kubernetes cluster, and it's still the same one-line Kubernetes command to spin up that application you want to run that you would normally do on a single server. And so orchestrators make it their job to manage a cluster of machines or a cluster of kernels, really, whether they're physical or virtual or somewhere on the internet or somewhere in your house. Those clusters are managed by a single Kubernetes API or Docker Swarm API or a Nomad API, because there's different opinions on these. Kubernetes is obviously the one we talk about the most, but there's lots of other options. And those runtimes, those APIs are just really talking to the Linux kernel through a container runtime. So we decided at some point that Docker would be a layer, right? So if we go back to that whiteboard, and I kind of move this around, and I talk about layers, right? So you have your OS. Let's just call it the kernel, because what is an OS, right? We all debate what exactly is a Linux OS today. Let's talk about the kernel. And then, so you have your hardware down at the bottom, or maybe it's the VM, right? The VM is emulating hardware, but that's not really the point here. So VM or hardware. Then you have some version of a kernel. And then when we do Docker, Docker is running Dockerd. And its job is to speak, to the kernel through system calls and talk C groups and namespaces. It also is dealing with virtual interfaces, doing the IPVS stuff, all those basic underpinnings, because it will give a fake interface or a virtual interface to each container if you want it to. And then at this point, now we have Kubernetes that sits on top of that. And actually that would sit over many servers, but in this case, it's going to be the kubelet daemon. Sorry for my horrible chicken scratch writing on the whiteboard. But I have actually a diagram that maybe will help you visualize, and this is a part of my Kubernetes mastery course, because we get to these so many different layers that it gets really challenging to understand how they're all talking to each other. But let me, I can't pull up one here. While I'm pulling this up, if you have a question you want to throw it in chat or just shout it out in the voice. So even on my Kubernetes mastery course, all the slides are public, even if you don't buy the course. The slides themselves are actually part of a, I'm having a hard time finding this slide I was looking for. All right, here we go. So there's lots of slides that show a lot of this stuff, right? But I'm gonna put this in chat and then let me, so in this, and can I see? Not sure if I can see this or not with the drawing. I'm actually gonna pull this up on my iPad so you can see it here. So one of the ways you can look at this is you have your infrastructure, and I'll bring up a screenshot of this because probably the best way to do it. All right, so we've got this infrastructure here on an individual node. And infrastructure is like the hardware, right? And the operating system in this case is whatever OS you chose to put on your hardware. Maybe it's Ubuntu, Debian, Fedora, whatever. And the container runtime in a lot of cases is Docker. Docker still, it runs on like 80% of the servers, even when they're running Kubernetes. We now have two other options. One of them is actually called Containerd. Another one is CRI-O. CRI-O is from Red Hat. So if you're an OpenShift person or if you're interested in Red Hat, if you have Red Hat infrastructure, you're probably going to be using the CRI-O. That's CRI-O. That is the runtime. And it's that job of the container runtime to talk to the operating system directly. So if it's a container runtime that can support Windows, it's actually going to talk to the Windows kernel in a completely different way, obviously, than Linux. And it's there. That's the job of that abstraction. And in this case, we're really just looking at this is a generic node, but let's just say this is a Linux node. And then there's these other agents that run on there for Kubernetes. If it was just a Docker system, we would only have this container runtime here. We would not have this kubelet and kubeproxy over here. But if you have Kubernetes, then you need these other daemons that they talk to the container runtime, and then the container runtime goes to the OS. So one of the core fundamental things around all these tools is to realize that you are always going to have a container runtime. It could be LXD, it could be something else. But if you're in Kubernetes world, there's three that are compatible, and that's Docker Engine or Docker-D, Containerd, which at this point is technically what Docker itself is running on. So even if you run Docker, you're actually still running Containerd. That's sort of the open source abstraction levels of Docker. And Docker just sort of wraps that Containerd with a really nice command line utility. Or you're running CRI-O if you're on OpenShift and Red Hat infrastructure. And then each one of your applications will be started. It's really just a regular process in Linux, right? But it's namespaced so that it can't break out of itself unless there's a 0-day kernel bug. It can't see the rest of the system. It can't see the real network interface unless you give it direct access to that stuff. And then if you happen to be in a larger infrastructure and you are running something like Kubernetes or Docker Swarm or Nomad, or AWS's ECS, then each one of these servers is replicating that. And then you have some sort of management infrastructure, which in this case for Kubernetes, we're running over here on the left side, which is a bunch of distributed components that all run separately. And they basically have a database, they have an API, they store configuration. And it's the job of all these orchestrators to manage state. So their whole thing about orchestration is simply looking at what's running in the cluster, all the applications running, and then look at what the database has or what is supposed to be running and just resolving the differences. So it's just a state engine looking at real time, looking at what I've been told to run, making sure they're the same. If they're not the same, resolving those conflicts. So it's just sitting there constantly polling, resolving conflicts. So when you tell it to run 5 MySQL databases, it looks at the database, it sees that there's not 5 running, and so it doles out work to each node to figure that out and to run those containers. The reason that it's so magical for us, if you're on the operations side, if you're a sysadmin, the reason this is all awesome is because it gives you, regardless of the infrastructure you're on, whether it's 1 machine, 100 machines, 1 cloud, 5 clouds, it gives you a consistent experience for, delete that. It gives you a consistent experience for managing your infrastructure in terms of how do you package your applications? How do you store those applications in a central repository in terms of artifacts? How do you store those? You know, we have Yum packages and apt packages, but think now of Docker container images as now this is the next level of packaging. It's the same, the packages work regardless of the architecture, regardless of which OS you're on, because you can have the same registry store packages for 32-bit, 64-bit, ARM, AMD, Windows. And then it has each package also has all the dependencies. So your dependency management that's not really a solved problem, but it becomes a lot easier than previous automation tools we all had for managing systems. And so now that you've packaged up all the apps and their dependencies, now you have a central repository for storing them and distributing them. And then you have a common runtime across all your different systems for now pulling those packages down and executing them. And then you have this new orchestration layer that if you want to do that, you don't have to do orchestration, but if you want to, that now tries to solve a larger problem of managing all those decentralized systems with a single set of tools. It starts to solve a lot of the traditional problems where we were solving them with, you know, scripting and a lot of tearing down servers and spinning up servers and manually configuring them through Python and, you know, Ruby and Bash and all that sort of stuff. So it gives us new problems. I will not lie, there are plenty of problems in containers. So if there's any questions on that, I'm going to wrap that up in terms of like the basics of the architecture and infrastructure. Most of you have probably seen a Docker run example, but I can give you one if you'd like. So, any questions on that? Anyone have any questions while we're talking about architecture, the components, the internals? You can throw them in chat, or you can jump on audio if you'd like. All right, I'm going to jump ahead and back on our survey from the chat. We talked about Docker basics. So the Docker basics of the command line, I'll give you a couple of quick examples of what this might look like is the reason that you might be interested in Docker. There are lots of other tools, by the way. I think one of the questions I asked was Docker versus Containerd versus Cryo versus Podman and over here. And really, there's tons of tools now that we have to manage images. So there's building of images. That's taking your application and all its dependencies. And when I say all dependencies, I mean everything other than the kernel drivers, hardware drivers, anything that would be device specific. So those aren't going to be in your images. And your images are going to contain, so if it's a Java application, it's going to have the Java runtime in that image. It's going to have your application code in that image. And anything that, if you can imagine a bare Linux operating system, sort of imagine if you spun up your own Linux OS and then you mounted a new file system, and that application had nothing other than access to that empty new file system. So it was only mounted to that empty file system. And if your application needed bash, for example, that would have to be in the container image. If it needed a Python runtime in order to run the Python app in your application, then you would have to have Python in your image. So it basically starts with what we call a scratch, or a blank canvas on the file system. It can still do system calls because it doesn't need to have the kernel in it. That's still happening through the namespace and C group stuff. But it's really just there empty. And so when people start out, they know maybe it's a little too much magic going on, and they don't realize what's happening when they do a Docker run command. And that's all it's doing, is it's looking on the file system. You still have to worry about your path inside the file system of this Docker application. So when I'm going to go to this is actually from my Docker mastery course. So if I go to like a Docker file sample, one. And so you have to concern yourself with this new type of file called a Docker file. It's a little bit like a shell script, but it's quite not a lot like a shell script. It is something unique to Docker. If we just do an example here real quick, is it always has a from line, and that basically allows you to have images that depend on other images. So you can have these layers of images. So Docker and the community all provide a lot of the common open source tools as images, and then you can start from there, because each one of these commands becomes a layer, and each layer is like a diff on top of the layer before it. So in the background, Docker is also applying a storage driver that uses what we call a copy on write storage driver file system. And you might heard of names like device mapper or overlay, stuff like that. And Docker's managing all that for you. And what it really means is if I want to pull down a new application and I do something like Docker pull, node. So I want to run a node application. So I want the full node command line experience. And I want to pull Docker node version, I'm going to do version 10. I'm not going to do Alpine. It's going to pull all these different layers, and it can pull them at the same time. And each one of those layers is a tarball that is compressed and pulled over HTTPS. Then it will do SHA hashing to make sure that these things are properly pulled from the right place. They're all being pulled from Docker Hub. And each one of those is essentially a bunch of file changes, directories and files, plus a little bit of metadata to describe the thing. And it will stack all those layers up when I execute a new container. So if I just did a Docker run, and in this case, I just want to run something in Node, so I need a command line with Node in it. So I might do a Docker run, and I would do an IT, which gives me a command line, and that basically gives me a interactive terminal, a pseudo terminal there. And then I'm telling it I want to run the Node image, and then I'm overriding the default command and saying I just would rather you just give me a bash shell into this new container I'm creating. Oh, and I didn't do latest, sorry. I should do node 10 like I just pulled. So I pulled the image, and then I can run. And this is me living in a Linux container that has only the things that were in that image. Now, Docker in the background did a bunch of other fancy stuff. It actually created a virtual network interface for me by default. It created that new file system that was only the files squished together into a single file system from all those layers. And then it gave me a shell. And of course, I had to have bash as an executable in that container in order to even run the bash command. And let's see. So if I don't have tree installed, but you can see that if I do like an apt command, or I do an apt get command or something like that, I'm doing that inside the container, which means that apt had to be in the container. So a lot of people first ask, well, why do I even need, Ubuntu as a container when when I have Ubuntu on my host? Well, that's because when you start a container, if it's not a file in the file system of the container image, it's not going to exist in that container when you start it. And that's the idea of these images, is the image has every dependency you need, and it's an efficient storage system. So each one of those layers that you saw me pull down, they're hashed, and they're not stored more than once. So in the background, Docker images are all stored in, if you've ever done any sort of deduping on a file system, if you've ever had to manage big file servers and you dedupe your bits and bytes on the files, that's sort of what Docker is doing in the background. When I pull down a node image or a MySQL image or a Python image, any of those layers that are identical via their SHA hash with any other application images, it will only store those layers once. So you get a nice efficient storage, which means if I run 20 node apps from the same node image, each one gets its own isolated container compartment, and the image is only stored once on the file system. And they're read-only on the file system, but then when each container starts, it gives me this read-write layer on top of it. And so here, I'm in the root of the file system, and I can actually touch a new file. And then if I do an ls again, you can see that it actually created the new file. So when I did that, I'm not changing the image. I'm only changing that new read-write layer on top of it. The image itself is the only way to change an image is to rebuild it, which is a different command. It's not a Docker run command. It's called Docker build. So your developers are making their applications, or they're writing their code. Then at some point, either they or automation, like your CI solution, your continuous integration, is building this new Docker image as an artifact. And it's storing that artifact in read-only fashion somewhere that's accessible by you and your servers. And that becomes the new workflow and the new way that your applications get on the servers, instead of having to work. And so you're not really doing apt-get on your servers anymore. You're doing Docker pulls, and all those dependencies, including any app dependencies, are inside the images. So that's why this particular application I have, I'm just running a node environment, so I can do which node, and I can see that the binary node is installed. I can see that apt is installed in here. So this file system and all these files were inside the image itself. And that's one of the things that took me a while to figure out exactly how that was working. For those of you that are Linux gearheads, that this sort of breaks down a lot of the magic that Docker provided, because you could do all this before Docker. Like, these were things that you could run commands in Linux to create these sort of jailed and chroot, stuff like that. But Docker's doing all this for you in the background. We have some questions. So each container duplicates the OS directories. So it doesn't actually duplicate it. It's only change on write. So if the image came with a file in it, and I decide in the container to change that file, then it will technically copy that file into a read-write layer. If we went back to Docker, actually has. I'm going to pull up an image, because I'm sure that there are images on the internet that are better than what I could draw. Yeah, so this image in the Docker docs is a pretty good one for showing you that. Imagine, so each one of these little blue boxes, or greenish boxes, are a layer of the file system. So each one of them is usually one of those lines in a Docker file. So it might be that one of the lines might be an apt-get install, right? Or and one of the lines might be you just doing some chmod on the file system, or it might be you copying in source code or something like that. And so each one of those is really just files and directories. And when they're created, that layer is set as read-only, and that's how you see the lock there on the right. That lock ensures that you're guaranteeing that you're getting the exact same thing that was put in that image. one of the problems that Docker was trying to solve was the works on my machine problem, which means I would run an app on my machine, but but it wouldn't work on your machine, and that's because usually because our dependencies were slightly off. I might have had a minor patch in Python or something, and different than your machine. And this is that's one of the things Docker's meant to solve, is it's giving you all the exact files and they're SHA hashed so that you know you're getting exactly what was built and tested. And that's why when you do CI testing, you should be testing in the image. So whenever you do any of your integration testing or any of that stuff that continuous integration would do, you're going to be doing that in the image you've built so that you can be sure that it passes in the image, because that's what's going to be shipped to your servers. And so you're going to want to test that. Now, when you run the container, that's this very top part, that thin read-write layer. That's the top part that's created. And so it's empty by default. When you start the container, it's empty. And then as you do something like I did a while ago, when I touch the file, when I create that file on the file system, it's adding that into this new read-write layer that's unique to this container. And that's how you can have the read-only layers on the image while also having that read-write layer on top. Because obviously, like your Node app or whatever you're running in your container, it doesn't know that there's layers of file system. That's the job of the storage driver. The storage driver is being run by Docker, and it's emulating a single file system by squishing all those layers together and all their differences into a single mounted file system. Let's see, what else we got in chat? Oh, yep, people are helping in chat. Cool. So the slimmer the OS kernel, more layers will have to be copied when pulling a container. I'm just thinking about this because I read that many companies are pushing for thin OSs like Core OS. Yeah, so let's talk about that for a second. So, I don't see a lot of traction on container OSs. So when we talk about a container OS, we're really talking about the operating system that's running on your hardware, whether that's virtualized hardware in virtualization, or whether that's physical hardware on a real machine. And the reason is because we've all spent decades managing real OSs, and well, in this case, what we're saying is Linux distributions. We're all managing Linux distributions. We're used to those distributions. We have tons of tools around those distributions. And a container allows us to move our concerns into the container itself and into the container images so that the OS on the hardware is a little bit less important. And in theory, you might be able to get to the point where that real hardware OS doesn't even need a package manager, because the only thing you're installing on it is Docker engine or containerd or some other container runtime. And then from then on, the only thing you're doing is running containers. Every single application is a container. So you really just depend on containerd or Dockerd to pull those images. So I have seen that. So we have things like Rancher OS, Core OS, but none of these have taken off. I haven't seen a single one in the wild or any company who isn't a container ecosystem player. If they're not dedicated to the container ecosystem, every company I work with as a consultant, all of my friends that work with containers in companies, I don't see a lot of that uptick, because the reality is, at the end of the day, is unless you're in like IoT or really specialized hardware, you've already solved these problems. You've already created your minimum OSs in terms of, the tooling you need on the host. You need SSH. You need, if you're doing it in the cloud, you're using a standard cloud image. So the minute you try to go to one of these new distributions, you have to retool everything. You have to change all of your scripting and automation and your OS deployment and your patch management and your, all that stuff has to change. So I don't see a lot of teams doing that because there's not, we're all busy. So there's not a lot, they don't perceive a lot of benefit. Maybe if you had 5,000 servers, you might see a benefit. But if you've got 50 servers or 300 servers, shifting from, a very minimal Ubuntu or Debian or install to something like, let's see, like a Core OS or a Rancher OS. In fact, Rancher OS and Core OS, I think, are both legacy at this point. I think they're actually deprecated because they're moving on to other concepts of what a container OS is. And what a container OS, we're calling it nowadays, really means that everything in the OS itself is also running in isolated containers. And that means that you have to have new package managers, new ways of updating. Teams that are like Netflix, they're already doing all of this. They create operating systems when they spin up new VMs, and if the OS needs to change, they throw it away and they spin up a new one that has new updates, right? So if you're at that level, then you're already solving these problems. But for those of us that are not there, and most of the people I work with are not. In fact, everyone I work with is not not Netflix. So they already have all this tooling. And so what we're doing is we're spending more of our time not trying to change the underlying OS. We're spending more time at higher levels of abstraction. So we're deploying more automation like Kubernetes and more tooling on top of Kubernetes, like what we now call operators, which are essentially plugins that allow you to automate Kubernetes and all your applications in Kubernetes with more intelligence. And you see people doing things like monitoring on top of Kubernetes, centralized logging on top of Kubernetes, maybe deploying tooling that automatically backs up all your containers across a cluster. My show, by the way, the Bret.live show, if you go there, we had a lot of demos this spring from some of the open source projects on top of Kubernetes, like ones that will do automated backups of the cluster, as well as the containers running inside it and all their persistent storage, database aware backups, database aware replications, stuff like that. So that's where I see a lot of people focusing their time, and the underlying OS, we haven't been really changing. I'm not saying that won't change in the future, but it's an interesting discussion because I think it was the idea of a really lean, thin OS, something like Alpine maybe, which Alpine is technically not a container OS, but if we pull up Alpine, Alpine Linux is a very small OS. So it's going to be a much smaller install than like a Debian or a Ubuntu. And it is gaining popularity, but it's also, it changes the way that you install packages. So all of your scripting and automation has to change to use their package manager, not your apt or your Yum package managers. And, there are nuances and subtleties and problems with Alpine that you don't get on a more traditional like Debian approach to things. So I don't see a lot of teams changing because they're very, very comfortable with what they're already doing there. The problem is now they have all these new layers like containers and container orchestration and all that new tooling that they have to use. And they're too busy focused on that to try to change the underlying systems. But doesn't mean you shouldn't. You maybe should do that. I just don't see a lot of teams having enough time to do a lot of that. So it's a great conversation to have though. Yeah, and so Chris is saying containers don't contain a kernel OS with them, so keeping layers small is mainly about making them quick to pull. So there is a difference between the management and the slimness of the host OS or the hardware-based OS and what is in your image, right? So if you go to Docker Hub, you will see, here's a great example. If I go to I've been using Node, but I'll switch over to Python real quick. So if I go to the Python image page for the official images, you'll see I say it says Docker official image. So there's about 150 to 200 official images. They're mostly open source applications. And I say mostly because there are Windows-based ones that maybe aren't open source, like Windows itself, that you can actually get in images. But you'll see all these tags, and tags are the ways that we define different types of images or different versions of images. We call them tags. And you'll notice that you can do all sorts of things with these tags where we might have Python running on Windows. We might have Python running on different versions of Debian. And you'll notice we have something called Slim. And so in a lot of images, especially ones that are focused on a programming language, one of the key things you learn is that there are the defaults, like just the Python image, and then there are the Slim images, and then you might even find an Alpine image. And the Alpine image tends to be the smallest, but it also tends to be the most limiting. It has the least number of tools built into it. It has a different type of package manager that's not using apt. It's using the Alpine package manager, APK. So your team will have to choose those. You will see on my YouTube live channel that we have lots of opinions, and I like to give them because after years of experience, not everything you read in marketing is true. So I try to be less markety and more real world, feet on the ground. You know, nothing's perfect. Everything has problems. There's no perfect answers to anything. So I tend to actually shy away from Alpine and tend to focus on Slim, because Slim keeps me on a very compatible Debian apt experience with apt-get and all those commands that usually run really well with all my scripts, and my engineers and my administrators and my developers, they all know that. They don't have to relearn a new packaging system, new package format. They don't have to learn a new C compiler. And so they like that experience. But Slim gives me a much smaller image that's much smaller. So like, for example, if we go back down to my command line and I do a Docker image ls, you can see I have a whole bunch of images here. But if I do a Docker pull, let's just do a Docker pull Python. And then I'm also going to do a Docker pull Python Slim. And then I'm also going to do a Docker pull Python Alpine. So these are all three, and I could technically, if I had a Windows machine, I could do a Docker pull of Python on Windows, because I could do the Windows binary executable of Python if I was running on a Windows machine. So all of these, now if I do a Docker image ls, oops. All right, so you'll see I've pulled 3 different images, and these are all the latest releases of Python built on a different dependency stack. So what we call the default, which is also known as the latest image, that is 900 meg. We'll get to why it is 900 meg in a second. And then you'll see the Slim image, which has a lot less of optional dependencies, is only 165 meg. And then if I chose the Alpine, it's about half the size of the Slim. Now, in my opinion, the difference between 79 meg and 165 meg is not a huge difference. So I wouldn't, in my case, in most of my cases with customers, unless we're running on like an SD card on IoT in the field somewhere on some sort of weather sensor that's running in a tower somewhere, I wouldn't really worry about 70 megs of space that I needed to preserve. I would focus up more on if I'm going to use Debian, which it just so happens that if you don't specify, everything's using Debian underneath. And again, this isn't the Debian kernel. This is really just the standard dependencies of what you would expect with a Debian server. So that means the versions of Bash and other shells that would come with Debian, or the version of apt that would come, or the version of OpenSSL and OpenSSH maybe, so that you could use the SSH command inside a container. All those sort of typical things, right? The root certificates that you need in order to even do things like apt-get install. All those things have to be in the container image. And so if I chose latest, I would be getting the Debian experience, but it would also come with a bunch of C compilers and other optional things. And that's why it gets up to be up to like 900 meg, because it's got all these dependencies. If I looked at the Slim, you would see that most of those are taken away. And then Alpine would be using the Alpine-based image, which in this case, Alpine is actually using something called BusyBox. I don't know if you've ever heard of that, but BusyBox is a very, very small Linux distribution that basically can run on a floppy. I think it's less than 1.5 meg, so you could run on a floppy if anybody knows what that still is. But if I go back over here to my images, you could actually find out where these come from. You can dig in yourself and click on one of these. So if I just look for latest, all right, and I go find, so this is the latest, has the latest tag on it. So it's using the Buster distribution of Debian. And I can go look at this file and see exactly how it was built. So I can see that, it came from another image called build packs or build pack deps, right? So then I could actually copy that if I really wanted to. If I wanted to find out what was in there, I could go over to Hub and just search for that particular image. And you would see that that's the official image for build pack deps. And I could start digging into this one as well. And because it was based on build packs deps with the buster tag, I don't know if you can see that, build packs dep buster, then I can go look at that build packs and look for the buster one. There we go. So yeah, so I've got this buster one there. So then I can click into that Docker image. And so we keep going up the stack. So I can look at this image. It's built from this image. I could go there. And so each one of these, you could go and see, okay, so what's in this particular release? And you can see in this one, there's a whole bunch of apt-get installs. And you see all these build tools, all these libraries for development purposes. And so that is what is in, so when I walk up the stack essentially, and I go back to that Python image, that's what that default Python is made from. But if I then go down and find the Slim, this is the Slim one right here. This is the most recent Slim. And I go in there, I can see that it's based on a Debian Slim. And if I go look in that image, then I would also find that it doesn't have near as many of those apt-get dependencies, and that's how it gets smaller. And so this is how I learned, like 5 years ago, 6 years ago, this is how I learned what was in Docker. Another way you can learn, I'm going to take some more questions here in a second. I'm just going to show you this really quick, cool utility that is a very good demo from the command line called dive. So I can dive into, I'm going to go into Python Slim. So dive is an image discovery tool that will jump into an image and its layers. And you can get that over, if you just dive. I'll put this in chat. This is on GitHub, open source utility that gives you a terminal view. By the way, those of you, I don't know if you're, some of you, I don't know if you're sure if you're realizing some people are still putting questions privately. Make sure your chat is set to everyone so everyone can see those questions. So the dive tool allows me to inspect inside an image, and I can see the size of that layer. So each layer, the command that was run to make that layer, and then I can even browse the file system for that particular layer. So for example, if I'm in this apt-get layer, you can see that it's 7 meg in size, and then I can kind of dive down into inside that layer. It's showing me inside the bin directory. I can navigate up the file system. Let's see, control space, and then I can, if I want to see what's in the home directory, well actually there's nothing in there. I can go inside of user and kind of dive down through a file system. And this is a really quick utility for local on your machine to understand what's going on in there if you want to see the system internals of an image. All right, let's see what else is in chat. Okay, so great question. It's interesting that you talk about architecture. How does a Docker image work on both 32-bit and 64-bit architectures? And are there any issues when you run a 32-bit image on a 64-bit host? So there is, it's actually a little bit magical to start, but it's not actually magic. I mean, obviously, right? Like, there's no emulation here. There is no thing in the way running in front of your application to translate it. What it simply is Docker knows the engine that it's running on. So if you're running in the Docker command line, if I'm on a system and I'm in the Docker command line, I have two parts to my Docker. I have the Docker CLI and I have the Docker daemon or the Docker engine. And the CLI is when I type on the command line, that's the binary I'm executing. And that it can be on any system. You can see on my machine, it's actually Darwin. I'm actually running on a Mac. And that is my command line. But my server, where the engine daemon is running, is a Linux architecture. And the way that my command line is talking to it, by the way, this is totally the same way that Kubernetes works. So that engine is running on a Linux kernel inside a Linux VM. It just happens to be running on my Mac, but it could be running anywhere. It could be running in the cloud on a different server somewhere. And it can use either sockets or TCP or even SSH to communicate between my command line and that server. So that server engine right there it knows that it's running on a Linux kernel and it's running on an AMD 64-bit compatible hardware. So those are the two parts of it, right? Because it could be Windows AMD 64, it could be Linux ARM 64, it could be, you know, PPC, it could be a mainframe. There's all sorts of them. And I can also see that kind of stuff in a Docker info command. I can actually see more stuff about my Docker system and its configuration. I can see with that Docker info command, I can see everything from the drivers and the file system and the storage. I can see all these different URLs and how is it connecting. I can see different versions of things I'm running because Docker itself is running on top of the kernel, so I can see exactly what kernel I'm running on that Docker engine. All sorts of really cool stuff there. But one of the things that it has is that architecture, the OS and the architecture. Those are the two key pieces of information. Docker in the background is using something called a manifest. And there's a manifest JSON file that is a part of every image that you pull from Docker Hub. And that will tell Docker which images are built for which architectures and OSs. And so one of the core ideas around Docker is that if I'm on a Windows machine on a 64-bit AMD running a Windows kernel, or if I'm on an ARM 64 Linux kernel, like running on an ARM Raspberry Pi, right? I want the Docker command line to be the same experience. And so what Docker's doing in the background is when I say Docker run Python, it's looking at the engine that I'm pointing to and saying, well, that engine is running Linux AMD 64. So I will check for the image for AMD 64 Linux, and the image, if it doesn't see that image, it will pull down that image to make sure that it runs on that architecture. If I then change my Docker command line to point to a different system, and you can do that with Docker context. So I can look at a different system, and if that different system where the daemon's running somewhere else, if that's running a different OS and architecture, when I do a Docker run Python there, it will go to the Python repo, and it will see if there's an image manifest that matches that OS and architecture. So there's no voodoo here, right? So technically, if you're an application builder, you would have to build your image for each one of these architectures. And when you upload them, you can upload them to the same repo. And that's how, when you're looking at Python here, you see all these different tags right here in the middle of the page. So you'll see that there's IBM Z, there's ARM, there's ARM 64, there's 386. So if I wanted to do an old ARM or even a PowerPC, I could click on these, and it will filter. Well, actually, what it does is it goes and shows me all images across the entire system that run on that particular. So right now there's 6,000 images that are built for PowerPC. But what I really want is to go into tags here, and I can filter and search by the tags here. So I might, if I'm someone that's ARM, I'm going to look. So you see how, like, this is the release client. I really don't want RC. I probably want something a little more stable than RC. So maybe I will look for, let's say I'm running to run the 3.9 version of Python. So I can see the OS architecture here, right? And you can see that even here's the digest, so I can get the exact version of that image. But Docker largely solves this problem for me. I don't have to know this particular digest or specify this usually. There are a few cases, usually on Windows, where you can actually run both Linux and Windows, and in the background, Windows does some fancy stuff that no one else does, where they automatically decide whether to run it on Windows or in a tiny little VM. But you can see here that this is basically all different builds that someone built of the Python image and then pushed it up to the same repo. So hopefully that makes sense. The idea here is that operators and developers don't have to know every architecture difference and nuance, as long as they're using an image that has been built for their architecture in OS. They can just run the same command as they've always run, and it will determine the rest automatically. The container host OS are more Kubernetes focused these days. If you're spinning up a KS cluster, you're probably using a dedicated OS. Yeah, especially if you're doing something in the cloud that the cloud is providing. They're gonna pick their own OS. Yeah, I mean, so the summary of the thin OS and on your hardware is you'll know when you need to solve that problem, right? Usually, when you jump in a container, there's so much new stuff to learn that you're trying to learn all these new tools, but you don't necessarily need to go replace your OS. I'm always a fan of sticking with what you know, and if you know a particular distribution of Linux, stick with that. If you know that, stick with that. Almost always, Docker will run well on that OS, unless it's really old. Yeah, as you recall, one of the drawbacks of Alpine is it's using ulibc. Yeah, so there are a few of them, and Alpine Linux on a physical host is different than Alpine Linux in a container, because when it's in a container, it's using BusyBox, which is a whole other project that bundles all the different binaries into a single statically built binary. So you'll want to learn, if you want to learn about running Alpine images in Docker, you'll want to learn about BusyBox, because that's really the base OS parts inside of that are all using BusyBox. All right. Yeah, and someone mentioned BuildKit. That's a really cool tool that we won't have time to talk about. BuildKit is a new way to build images that, for example, if I get out of here, if you've ever done a Docker build command, if I do this, I do like a Docker build in this directory because I have a Docker file. Actually, I want to do it up a notch. Let's see, Docker file sample. I'm gonna do this one. Let's see there. No, that one's boring. Boring. Oh, this is the ultimate Docker file. Let me do that. It's a really complicated one. So in my Docker for Node.js course, the file. Oh yeah, this is a super complicated one. All right, so let me see if this builds. So I have BuildKit, which is a new feature. So we'll finish up with this because I think we're talking about what's new in 2020. So there's not a ton new yet in 2020. I just did a live show today. If you go to my Bret.live, right, this little thing over here, over there, Bret.live, you'll see the live show today. We talked a little bit about a brand new thing where you can do a Docker run directly against Azure's container infrastructure. So it allows you to basically not have to concern yourself with making a VM. You can just deploy a container from Docker run. It will instantly run on Azure. And so that's a brand new beta feature, just came out today. There are a couple other things in Docker Desktop that's for Mac and Windows people that to basically run Linux Docker containers that are new this year. But most of the stuff we're still talking about here in 2020 is mostly around features that existed last year, because most people haven't gotten the news that a lot of stuff happened last year. So BuildKit was one of those things. And once you've enabled it, again, go to that Bret.live. I talk about it on my live show. If you just search YouTube for BuildKit Bret Fisher, you'll find some videos on this. But I have a really complicated Docker file here, right? Not code. Answer Docker file, yeah. So I have this, I don't know, it's probably like 100 lines. And I have a BuildKit enabled, which allows my builder that makes this image and puts all dependencies in there and copies all my code in. BuildKit allows me to do things in parallel. So like a really advanced makefile. And it also allows me to build at the same time on different manifests. So I can technically build across ARM, AMD, and all these different Linux distributions or whatever that at the same time with one command. I'm not going to do all that now, but if I do a Docker build, oops. Let's see, I need I'm going to call it ultimate. So it gives this new interface, and if you've not seen the new BuildKit interface, and it actually fails. I think I did a no cache. Let me do a no cache there real quick. So it'll be a little bit more interesting. So it's building my multi-stage Docker file. And if you're not familiar with multi-stage, that's a newer feature in the last couple of years that really gives you advanced abilities and workflows in Docker files. It helps you make them really small. Like in terms of your images, you can basically throw out all the things at the very end that you don't need, like your build tools. I do a lot of that in my Docker for Node.js course, which you can get. I think I put those up there earlier, but I'll put up there again because we've been talking for an hour. So I will put this in chat. But my Docker for Node.js is really not super Node.js specific. There are some things that are Node.js specific, but it's really about more advanced workflows in Docker for developers that need to build advanced images and run advanced Docker Compose stuff locally. The reason that this image fails, by the way, is because I have put into it some security scanners for vulnerabilities. So it will scan inside of my image while it's building it for any NPM. It'll do an NPM audit, which basically scans for any CVE vulnerabilities inside my image, and then we'll fail the build, kind of like a CI pipeline would, right? It would fail that build for my application and not finish building the image if it finds vulnerabilities. And it did, so it failed. But I could go on forever, but we've already been going on here over an hour. So any other last minute questions? I think we talked about half the topics in my poll. A quick recap on the containerd versus cryo versus podman. So if you're going to run Docker locally, let me go over here. If you're going to run Docker locally or run a container locally, even if you're on Linux, Docker tends to be the easiest way to do it, because that's the point of the Docker command line and the Docker engine, is to wrap around all these lower level concepts and give you really easy one-line commands to do it. So the thing about Docker, though, is it's opinionated. And it's relatively heavy, relatively meaning I run it all day long on my machines and it's fine, but it does not necessarily follow the age-old ideals around Linux and Unix around isolated different tooling that solve one problem. That is definitely not Docker. So if you are more of a fan of running 3 or more tools that do the same thing as Docker, then that's where the idea of Podman and Buildah, B-U-I-L-D-A-H, I believe that's spelled, and Scopio, and like Red Hat went the sort of the opposite direction of Docker. Docker was trying to bundle a whole bunch of different commands into a single tool to make it easy or easier for people to run containers without needing to know all the low-level tooling in Linux. Red Hat wanted a little bit more isolation in their tooling, and they wanted singular tools that had a singular focus. So with Red Hat, it's basically different strokes for different folks. So for Podman, for example, Podman is designed to run a container in systemd and use systemd as the container executor, and it is a wrapper around that workflow, but it can't build an image. So you need Buildah, a separate tool, to build that image. And then you might use a separate tool called Scopio, which helps you interact with registries and stuff, I think. So some people like that approach, and they want to have more isolated applications that they better understand what it's doing. Maybe they don't need to build images. They're only running applications, so they don't even need an image builder. And so they would do that. Containerd and cryo are largely about being a middle layer that is simply run by Kubernetes. And when you talk about cryo from Red Hat, it's specifically designed to only be a tool to run as a component inside Kubernetes. So that is taking away all the heavyweight Docker daemon stuff and really getting it down to the bare minimum container runtime tooling, just so that Kubernetes can manage it. And so that's why you see a lot of the container tools in the cloud all choosing to run containerd as their runtime, not Docker, because once you start running Kubernetes, you don't really use the Docker command line anymore. You're using the Kubernetes command line. So you don't necessarily need all those Docker commands. And so why have those on your system if you don't need them? So we run the lower level tooling instead. And so that's kind of the difference between all those. Yeah, nice advantage of Podman is that it doesn't have a client-server architecture and also supports non-root containers. Yeah, so that is a bonus of Podman, is that it's already using systemd. Whereas if you're using Docker, systemd would start up Docker daemon, and then whenever you're running the Docker command line, you're talking directly to the Docker daemon. And so Docker's daemon is designed to manage all the networking, it does all this networking stuff in the background, all the image management, all the container management. It even does things like snapshotting. It does all the image building, pushing and pulling. Whereas Podman is really just focused on starting and managing the workflow of an application like systemd would, but it's doing that on behalf of systemd and sort of managing systemd in the background. And I like that approach. I mean, if you're a real big systemd person and you don't want another layer of nested isolation like that, systemd can be a lean approach. The one thing is Podman is not designed to work. It's really an administrator's tool for managing one system. So like your local system, Podman is not necessarily something that you would use with Kubernetes. That's what you would use. Kubernetes running on top of either Docker or on top of Containerd or on top of Cryo. Podman is really meant for the administrator to manage containers on an individual server because it doesn't do clustering. So, but that's nice. That means that you can just use that tool just for itself. Now, when it comes to root, the last thing I'll say on root, Docker by default runs as root. There are lots of ways that you can isolate it. There's something called user namespaces in Linux that you can use with Docker. It doesn't come enabled out of the box, but if you just search the internet on user namespaces, you can find out how to enable it. And I have a list. I'm a big fan of security, and I have a special URL of my top 15 things you should be doing if you're going to be running containers. And I sort of left this at the end. We could have a whole talk on security, but go check that list out. And one of those things in that list is enabling user namespaces in Docker so that your containers will not run. They will have a further expanded isolation because even though the container itself is still isolated, so when you're root in a container, you're not really root on the host. But if you don't want to, you can run as non-root in the container, which I recommend you do. That's one of the steps here. And then one of the other steps is you can tell Docker to not even start the container as the root user, and it will run them under a limited user scope. And then if you want to run Docker, the daemon, as non-root, which is also what you can do with Podman, you can actually go to git.docker.com/ I think it's called rootless. It's not git, G-I-T, it's G-E-T. And so there's a script for installing Docker under the user context. So most people don't know about that, and it is experimental, but you can run Docker without any root privileges. And basically it will let Docker, it's still gonna run as a daemon, but it's gonna run as a daemon under your user account. And that script will allow it to run a container without needing that full root privileges. The negative there is that Linux currently still requires root privileges for creating virtual network interfaces. So if you're going to use the Docker networking functionality where it isolates the networking, it doesn't give full access to the host NIC, you're still going to need root for that, or you're going to need to set that stuff up before you create your containers. That's really a Linux kernel issue, I think, more than it is a Docker issue. So, but if you don't need those things, if you don't need advanced networking functionality, then you might be able to get away with it without having root. Yeah. So can you touch on running the Docker with command line options and then working out what those options were if you didn't note them down? Is there a neat trick to work them out? Maybe. So if I do a Docker run, so let's see, I'm going to run this command. Although I'm going to just name it. Actually, I'm going to make this is a weird, obscure command. So the answer is yes. One of them, without giving you a full demo on it, one of them is Docker inspect. So you can inspect a container, and it'll tell you the command it used when it executed. So in case you overwrote the default command, you can do a Docker inspect. So if I just do a Docker PS, I can see that I have one container running. But if I do a Docker PS-A, I can see all the containers that I've run in the past. And so this container right here with this unique ID, if I then just do a Docker inspect of that ID, one of the things you'll notice is this path in args is the command it ran on startup, along with the arguments for that command. So you can see how it ran. You can see things like, you can see all the stuff about it around, what storage driver it used, what image layers it used and where those image layers are, when it executed, when it finished. Did it exit with an error? Does it have an exit code of 1 or 127 or something like that? You can see all that in the inspect command. So the inspect is your friend. Like, you can get a lot of metadata out of that. The other thing is, if you did a Docker exec in a running container, right? So if you did like a Docker exec, which gives you a new, it runs a new command in an existing container. So Docker exec typically, it means you're usually going to do something like run a new bash terminal inside my running app. So maybe if you need to bash into a MySQL server that's running in a container, you would use Docker exec for that. Well, when you do that, there's the bash history inside the running container. So you could probably jump in the container, cat out the bash history or whatever you want to do to see the history of the commands run inside the container. Plus, you can also do things like a Docker save and a Docker commit. So Docker commit command will take a container and all the changes that happened inside that container during the running of that container, and will save them back to a new image. So any of those read-write changes you made during the container runtime, you would save those back to an image, and that's one way you can actually make your new image. That's something else you can do there. And then you could go in and inspect it and see what changes there were. So yeah, lots of ways you could do that. Great question. Best practice using a Docker Compose instead of running your containers by hand. Yeah, so that's a great answer from Brandon. Is I always use Docker Compose YAML. Unless I'm just doing a utility or a one-off command, I'm always using Docker Compose. Docker Compose comes installed with every Docker desktop. You can install it with pip. You can download it from GitHub. But Docker Compose is basically taking all those Docker commands and putting them into YAML, so that you only have to do things like Docker Compose up. And it can be a really complicated YAML file with lots of complicated commands, and you just have to do that same Docker Compose up, Docker Compose down. You can learn all that in my courses. That'll be my last little pitch. You go over to my courses, you can see all that stuff, bretfisher.com. And I talk a lot about Docker Compose in my courses because it's my favorite tool for running Docker locally for development and test. Again, you can see me live every week on YouTube. If you just go to bret.live, you can see me live on Thursdays. And I hope you'll show back up on the live stream. Say hi, tell me you're from the Linux meetup, and I will give you a shout out. And thanks for having me. And this is going to run really long, but you had a lot of questions. So
that is perfectly okay. Thank you very much for your time. I so appreciate it. I know how busy you are, and
we're all busy, but yes,
especially finishing.
Glad to be here.
Especially just finishing talking for an hour on YouTube and then coming over to hang out with us. Very, very much appreciated. And I'm going to go ahead and stop the recording now. So